When we consider the parabolic trajectory of a projectile, this is a graph that is essentially tracking its displacement. So if we want to consider velocity, well, we already know from previous work that velocity is the derivative of displacement. So if we wanted to consider, say the velocity at this point here, we would think about the tangent. So the velocity can be represented as a vector. And as with any vector, it can be broken up into its horizontal and vertical components. Now, clearly, the trajectory shows us that our projectile is being impacted upon by forces. Otherwise, if there were no forces impacting on the projectile, it wouldn't change direction or anything. Newton's laws tell us that. So what are the forces that impact on a projectile? Well, in the real world, we have two main forces to consider. The first is gravity, which we know acts downwards, and hopefully you're aware that acceleration due to gravity, so we'll say g, is about 9.8 meters per second. And yeah, that acts straight downwards, right? Especially when we're considering the ground as a flat horizontal surface. The other thing to impact our little golf ball here is air resistance. And so if our direction of motion is this way, then the resisting force is acting opposite our direction of motion. But for the Extension 1 course, we don't actually consider air resistance. We just consider gravity. So what impact is that then going to have on our velocity vector components? Well, because there is no resisting force in the horizontal direction, this horizontal component of the vector remains constant. And so at the very top of motion here, this is actually purely horizontal. And then down at this one, say when we're on the descent, we still have the same sized horizontal. So these are all supposed to be the same size. It is the vertical vectors, the vertical components of the velocity vector that do change because of this impact of gravity. So while it might begin with a significant vertical component, that clearly decreases until we get to the top of our motion, our maximum height, where there is no vertical velocity component. I mean, think about something, that just gets thrown straight up in the air, right? So we throw it as hard as we can. It goes up, it slows, just pauses for an instant, and then starts to fall again. That's essentially what is happening here, but we also have our sideways movement, our horizontal velocity. And so over on this one, we're back to the falling stage, so we have quite significant velocity, but it's in the negative direction, it's in the downwards direction. Now, in the last video, we talked about needing to know the initial velocity of the projectile, which we will call v, and we also needed to know the angle, which, like usual, is taken from the positive real axis, the positive x-axis, and we'll call that theta. So v is the initial speed and theta is the initial angle. And to break up the initial velocity vector into its x and y components, we can once again use our regular trigonometry. So in the x direction, we can use x to represent the x direction, but this is velocity in the x direction. So remember, we have the dot notation. And if you think of a right angled triangle, the hypotenuse is the v value, that initial speed, and then x is along the adjacent side, so we're using cos. And likewise for the vertical component, right, this is in the y direction, but we're talking about a velocity, so we have y dot, and this is v sine of theta. And so this is how we can express the horizontal and the vertical velocity components in terms of this initial speed v and the initial angle theta. So putting these two together, if we wanted to write down a complete vector for the initial velocity, we could write it as follows. We have v with our little tilde underneath to represent a vector is equal to its horizontal component, so v cos theta, in the horizontal direction, which we know we can use the unit vector I, plus our vertical component, which is v sine theta, and we can use the unit vector j, which is our unit vector in the vertical direction. So this is the expression for the initial velocity vector of a projectile.